Have you ever wondered what the moon will look like in 300 million years? Imagine for a moment that you have the ability to fast forward through millennia at an astonishing pace, witnessing the transformation of the moon's environment and appearance as centuries turn into eons. Today we embark on a speculative journey grounded in scientific predictions and theoretical models to explore the future of the moon. This celestial body, which has been a constant companion in the night sky, is set to undergo profound changes. Our mission is to unravel how these transformations might occur, delving into the dynamics of its orbit, the evolution of its surface, and even the possibility of it harboring life. As we set out on this journey, we'll use the lens of advanced scientific understanding to forecast and visualize these changes. From its craters and plains to its very core, the moon's secrets are poised to be revealed. Join us as we travel forward in time to uncover the secrets of our celestial neighbor. The dance of celestial bodies is a slow but relentless waltz. As we turn our gaze to our nearest celestial neighbor, the moon, its current dance with Earth is a fascinating study of cosmic synchronicity and gravitational interplay. The moon rotates on its axis and orbits Earth in a delicate balance that has been perfected over billions of years. To understand the moon's current state, it's essential to grasp two fundamental concepts: its orbit and rotation. The moon orbits Earth at an average distance of about 238,855 miles, completing this circuit approximately every 27.3 days. This is known as the sidereal period. However, because Earth is also moving around the Sun, it takes the moon about 29.5 days to return to the same phase, a cycle known as the synodic period. Tidal locking plays a critical role in the moon's behavior. This gravitational phenomenon means that the moon takes the same amount of time to rotate around its axis as it does to orbit Earth. As a result, the same side of the moon always faces Earth. This synchronization is a direct result of the gravitational forces between the Earth and the moon, causing the moon to elongate slightly along the axis pointing towards Earth, enhancing stability in its orbit. Looking ahead, millions of years into the future, the dance might change subtly. Scientific predictions suggest that tidal forces could continue to affect the moon's rotation and orbital distance. As Earth's rotation gradually slows, the moon is slowly spiraling outward at a rate of about 1.5 inches per year. Over millions of years, this could lead to a noticeable increase in the moon's orbital distance from Earth, potentially extending the length of a day on Earth as well. Moreover, the rotational period of the moon might also experience changes. Although these alterations are expected to be minute, they are a testament to the dynamic and ever-evolving nature of celestial mechanics. As the moon continues its celestial waltz, the steps it takes could look quite different millions of years from now. The moon's surface, a silent witness to the solar system's evolution. As we gaze upon the moon today, we see a landscape dominated by dark maria, stark craters and rugged highlands. These features, carved by ancient impacts and the slow but relentless process of solar radiation, offer a glimpse into the moon's dynamic past. But what changes might the next 300 million years hold for this celestial body? Firstly, let's consider the maria, those vast basaltic plains formed by volcanic eruptions billions of years ago. As time marches on, these dark patches may continue to erode under the persistent assault of micrometeorites and solar wind. This erosion could gradually soften their appearance, making the maria less distinct from the surrounding lunar highlands. Now turning our attention to the craters, these quintessential lunar features. New craters will undoubtedly form as the moon continues to encounter meteorites. Each new impact not only creates a crater but also throws up a halo of ejected material which can cover or modify older craters and maria. Over millions of years, this process might significantly alter the current topography, creating a layered tapestry that chronicles each event. The highlands, with their lighter shades and heavily cratered surfaces, tell the story of a tumultuous past. These areas, less affected by volcanic activity than the maria, might see the least change. However, they are not immune to the forces at play. Continued impacts and the steady work of solar radiation could further fragment the surface rock, slowly changing their texture and potentially their composition. Beneath the surface, the Moon's internal geological activity, though much less intense than Earth's, could still contribute to subtle changes. The release of internal heat might cause occasional moonquakes, slightly altering the surface over vast periods. With each passing millennium, the Moon's face is subtly reshaped, telling a new story of cosmic interactions. As we continue to observe and study, the Moon remains a key to understanding not only our own planet, but the broader mechanics of the solar system. Could the Moon ever support life? This question has intrigued scientists and dreamers alike for centuries. As we stand today, the Moon's atmosphere is incredibly thin, nearly a vacuum, composed mostly of hydrogen, neon and argon. It's a harsh environment, far from hospitable, with extreme temperature fluctuations that would challenge even the hardiest of Earth's organisms. However, the future could hold different stories. Let's delve into some of the scientific speculations about whether the Moon could one day develop conditions more conducive to sustaining life. One of the most fascinating concepts is terraforming, a process by which humans could potentially alter the Moon's environment to make it more Earth-like. Imagine, if you will, a future where advanced technologies could enable us to thicken the Moon's atmosphere, regulate its temperature, and introduce water and organic materials. The idea is to create a biosphere where Earth plants could thrive, producing oxygen and supporting a cycle of life. While this might sound like science fiction, advancements in technology and our understanding of ecological systems could turn fiction into reality. Another intriguing possibility lies in natural atmospheric development over millions of years. Just as Earth's atmosphere evolved from a mixture of volcanic gases into a life-supporting blanket, the Moon could also see transformations. This would depend on numerous factors, including volcanic activity, comet impacts which could deliver water and organic compounds, and perhaps even the introduction of hardy microorganisms from Earth that could adapt and evolve. These scenarios stretch the imagination and our current technological capabilities, yet they highlight an essential truth about our universe. It is always changing, and the possibilities are as limitless as space itself. As we ponder the Moon's potential, we must remember that the boundaries of life are not fixed, but evolve with the universe itself. Every celestial change sends ripples through its cosmic neighborhood. Imagine the Moon, 300 million years from now, evolving in its majestic orbit around Earth. As the Moon experiences changes in its orbit and rotation, the effects on Earth are profound and multifaceted, particularly concerning our tides, night sky visibility, and even the very spin of our planet. Tides, those rhythmic rises and falls of our oceans, owe their existence to the gravitational pull of the Moon. As the Moon's distance from Earth increases over millions of years, its gravitational tug weakens. This leads to a noticeable decrease in the amplitude of oceanic tides. Such a shift could alter coastal ecosystems, which have adapted over millennia to the current tidal ranges. The intricate dance between the Moon and Earth's waters is delicate, and even small changes can echo across marine life and coastal geographies. Turning our gaze upwards, the night sky too would transform with the Moon's evolution. A more distant Moon appears smaller in the sky, dimming its silver light. This subtle fading of moonlight would enrich the darkness of the night, allowing more stars to twinkle to their full potential, thereby redefining the celestial canvas observed from Earth. Furthermore, the Moon's gravitational influence plays a crucial role in stabilizing Earth's axial tilt and rotation. Changes in this dynamic could lead to variations in Earth's climate and day length over geological timescales. A less stabilized Earth might experience more dramatic shifts in weather patterns and temperatures, affecting biodiversity and weather systems globally. The fate of our Moon and Earth are inextricably linked, each shaping the destiny of the other. As we gaze up at the night sky, the Moon reminds us of the vastness of time and space. Throughout our journey today, we've explored a vision of the Moon 300 million years into the future, a canvas painted with the strokes of astronomical forces and geological evolution. First, we considered how the Moon's orbit and rotation might evolve. imagining a celestial dance slowly changing with time. The subtle shifts in its rotation could alter how we see the moon from Earth, presenting a slightly different face to our descendants. We then delved into the moon's surface and geological changes. The constant battering by meteorites, the shifting of lunar regolith, and possible volcanic activity could reshape its ancient scars, creating new landscapes in the stark lunar light. Our exploration took us even further, speculating about the moon's atmosphere and its potential to harbor life. Could microbial life find a foothold in the lunar soil? The possibilities stretch our understanding of life in the universe. We also pondered the moon's impact on Earth. Its tidal forces have been partners in shaping our world's biological and geological rhythms. What changes might occur if these forces shift? The interplay between Earth and its satellite is a delicate balance, one that affects both bodies in profound ways. In contemplating the moon's journey through time, we find a mirror reflecting our own place in the cosmos. Thank you for joining us on this remarkable voyage.